So I'm not real pleased with my day one, so I'm basically redoing day one of a parabola. And we talked a little bit, okay, how you graph it in vertex form, but I never really talked about how you get it into vertex form. So what we're going to do, I'm going to do a handful of problems, and like in these questions, so this is your homework for tomorrow. It says, use the information provided to write in vertex form the equation of each parabola. Now, just so you know, when I say vertex form, this is what I'm looking for. I am looking for y equals something squared plus, I'm going to put the letters in, actually. Let me see. A, H, and K. Does that show up? No, I have this set on the wrong side. So, vertex form of a parabola is y equals some number, I'm going to call that a because every book calls it a, x minus some number h because every book calls it h, plus k, some number k, and every book calls it that. And your job for all of these is to make them look like this, right? Now, how do you do that? Well, let's kind of refresh our memory of things that we talked about on Friday. See, on Friday we had, if I gave you y is equal to 2x minus 3 squared plus 4, or maybe on Friday, but a week ago when we talked about a parabola, turns out this number and this number helped us figure out what a vertex is. Like, it was easy to graph this if it looks like, it's easy to graph this parabola if it looks like this, because our vertex is going to be located at 3, 4. Because this is telling us shift it to the right 3, shift it up 4, and so our vertex is at 3, 4. So if we know, if it looks like this, we know what our vertex is. All right? Let's go backwards. What if I told you I want my vertex to be negative 2, 1? Right? As far as going backwards, if I want my vertex to be negative 2, 1, how could I create a parabola in vertex form? Well, see, everything's sort of set up where it's y equals, something squared plus something. And your job is to figure out what goes in for the a, what goes in for the h, and what goes in for the k. Well, this is your h and this is your k. So that means this number is going to go here and this number is going to go here. Right? See, that went from here and that went. Like this gave you this number, this gave you this number. So going backwards, if this is the x part of your vertex, it goes with the x. This is the y part, it goes over here. And this is going to give me x minus a negative 2 plus 1. So when I simplify this, I get x plus 2 squared plus 1. Now, some of you may say, well, you might look at, well, what about that number in front? Well, we're going to deal with the number in front in a little bit. But I just want to make sure we're okay with the, if I give you a vertex, you know where it goes. So, okay, all right. All right, so now given that information, and this is going to tie in, what I want everyone to do, so what we did Friday, we talked about, a lot of what we did Friday is I gave you stuff that looked like this, and I said find the vertex. So if I give you, and our vertex had an x part, and it had a y part. And the x part we had was this negative b over 2a. So for question 1, I want you to find the x part of the vertex, and when you find it, do the electronic raise your hand. Yay, all right. So let's see. Negative b, so negative 16 over 2, and so my x part is going to equal a negative 8. So now I know my vertex is going to be negative 8, comma. Now I got to find the y part, right? So find the y part. 16 times 8 is 128. If you're curious. So let's see. Plug that in. That's going to give me 64 plus, actually it'll give me a minus 128 plus 71. And where's that off from 64? 7. Is that a plus 7? Yeah?
Yeah.
I think that's a plus. So we found our vertex is negative 8, 7. All right? So now to put this in vertex form, I'm going to do y equals x something squared plus, yeah. And what goes in here, what goes in here is the x part. So I'm going to put a plus 8, and what goes over here is the y part, so I get a plus 7. And you can kind of check, the opposite of this goes here, and this number goes here, and so I've matched my vertex, and here's my equation. Now, kind of the cheap way of doing this is whatever number's in front of the x squared, that's the number that goes here, and since there's a 1, I get a 1 here. All right, your turn. I want everyone to do problem 2, find the vertex, and then write the vertex form, and do the electronic raise your hand when you're done. Now the y part means I got to plug the 1 in, so let's see, that's 1 minus 2 minus 5, so I get a minus 6. So I know that my vertex is 1, negative 6. And now that we've got our vertex, we can write the equation, and our equation is going to be y is equal to something squared, and a number off to the side. Well, what goes here? Well, what's going to go here? We know there's an x. If I want a 1 here, that means I need a negative 1 here, and I need a minus 6 on that side, and the number in front of this is a 1, and so I've got my answer. Okay? Let's see. Let's do one more before I do some of the tricky ones. So now I want everyone to do problem 6. Plug it in, fit it into this formula. All right, well, that's nice if I give you what you're used to. What if I don't give you what you're used to? Okay? Because when you look at this, like most of this, I'm giving you exactly what you need, or exactly like the problems you're used to dealing with. But when you look at 8, not quite the same, is it? Right? Because everything else is like, okay, well, what's my A, what's my B, right? Because that's how all this stuff works. Well, unfortunately, if I don't give you something that you're used to seeing, you have to make it look like something that you're used to seeing. Okay? So if you're used to seeing x squared and x and a number, and I don't give you that, make it that way. So when I go through this, if I multiply it out, I get x squared plus 9x plus 20. Okay. Now I've made it look like something you're used to dealing with. And that's the good news. The bad news is sometimes you don't have nice answers. Like for this particular one, if I do negative b over 2a, well, let's see. This is going to give me negative 9 over 2, which is yay. Negative 9 over 2. I know a lot of you like dealing with decimals, and I think the reason a lot of you like dealing with decimals is you're used to always having a calculator, and so you just don't like fractions. Now, the issue you've got is, believe it or not, once you learn to deal with fractions, it's actually a lot easier. right? But, so what I'm going to do is, I've got to figure out the y. So you have two choices. You can plug that 9 over 2 into this, or you can plug it into the original equation. You're going to get the same answer, but you're going to find out your job's a lot easier if you plug it back into this thing. So let's see what happens. So I get negative 9 over 2 plus 5 times negative 9 over 2 plus 4. And I might be dragging some of you kicking and screaming, but if we get a common denominator, that's going to give me 10 over 2. If I get a common denominator, that's going to give me 8 over 2. So I end up with, so going to give me a positive 1/2 times a negative 1/2. And while you may not have liked dealing with fractions here, I'll guarantee you like dealing with fractions here as opposed to decimals, because 1/2 times negative 1/2 is not hard. We just end up with negative 1/4. So I just found out my vertex, the x part is negative 9 over 2, and the y part is negative 1/4. And doesn't really matter what the numbers are. The formula still works. It's going to be y equals some number x plus 9 over 2 squared minus 1/4. Sit on. It doesn't matter that these things are fractions. I'm not asking you to graph it, right? I'm just asking you to create this. Let's see. What's next? This is kind of the same thing. Hint for number 10. You're used to seeing y by itself. So since you're used to seeing y by itself, make y by itself. If I make y by itself for number 10, that's going to be y equals negative 6x squared minus 12x minus 13. All I did was move everything else over except the y. And what I'd like everybody to do at this point, as I haven't done one with a number in front of the x squared, is I want everyone to find your vertex and find the vertex form. And after you do that, do the electronic raise your hand. All right. So in problem 14, I want everyone to put this in vertex form. It's supposed to be easy. And when you put it in vertex form, right, then do the electronic raise your hand. Now I'm going to stop everybody for just a second. The reason I'm going to stop everybody is you don't have to do hardly any work. If your goal is to make it look like standard form, like everything else, all you have to do is subtract 6. And when you subtract 6 from both sides, you end up with y is equal to x plus 3 squared minus 6. So that I actually think is the easiest problem here. And let me make sure I make sure I did this properly. Yeah, your goal is just to write the vertex form of each equation. All right, and then I've got 6 problems that I want you to graph. What I'm going to do is I'm going to do one of them, and then your job is to do the rest of it. And like we'll start on in class and then finish the rest for homework. I'm going to do problem 16 because I actually think that's probably the ugliest of all of these. And so I want to talk about what I want. How do you graph a parabola? Because on your quiz on Friday, I'm going to have you graph a parabola. Now, if I'm going to have you graph a parabola, I should probably tell you, at least how to do it. I mean, make sure, tell you what I expect. So, if it's in vertex form, here's what I expect. I expect you to tell me what the vertex is. So in this case, your vertex is 1, 4. And so you go 1, 4, and you put a dot. Next thing, I expect you to know, because there's a negative here, it's a sad face, so it's going down. I don't think that's unreasonable. Now, there will be a long list of things that we have to do, but for this one, all I care about is the picture. And how do you get a picture? I need a dot on either side. Right? Because a parabola, it's symmetric, so once you get the vertex, you need a dot on. If you find a dot on this side, then you know there's an exact copy over here, and then you can get an idea of what it looks like. So what do you do with that? Well, so you got to find one dot. How do you find one dot? Well, you got to plug values in. And that's where it gets kind of sneaky, right? Bit of a pain. Because what you want to do is pick x values that give you nice values. And I'll go ahead and give you a hint. You're going to get a nice value, right? If your x, like your vertex has an x value of 1, you're going to get a nice value if you pick something close to 1. Now sometimes you can get very close to 1, like you could pick 0 or you could pick 2. And sometimes that works. Actually, most of the time it works. It's going to work for this one. It's basically going to work for anything that doesn't have a fraction. But if it has a fraction, sometimes you have to go a little bit further away. And so for this particular one, so when I plug 1, I get 4. When I plug in, I'm going to not plug in 2, I'm going to plug in 3. And you'll see why that gives me a nicer answer. And when I plug in 3, let's see, and this is going to give me negative 1/4. 3 minus 1 is 2, so I get 2 squared plus 4. And if you look at this number, you can see we're going to cancel out a fraction, because that's going to give me a negative 1/4 times 4. Negative 1 plus 4 gives me 3. So at 3, I'm at 3. Now once you've got this dot, notice it's like I went down 1 over 2. So I'm going to go down 1 over 2 this way. And I'm going to do the best I can to draw my little parabola. And that's what I expect for these. All right.